How you doing? I'm Kenny Joya. Welcome to another one of my tutorials. In this series, we're going to learn about phase. Phase is a term used to describe the position of one sound wave relative to another. Two identical waves are in phase when the crests, or the highest positive points, and troughs, or the lowest negative points of the waves, meet or are in sync with each other. And they're considered out of phase when the crest of one wave meets or is in the same position as the trough of another wave. Phase shift is the difference expressed in degrees or time between two waves having the same frequency and reference to the same point in time, as in a single sound source. Two oscillators that have the same frequency and no phase difference are said to be in phase. Two oscillators that have the same frequency and different phases have a phase difference or phase shift, and the oscillators are said to be out of phase with each other. The amount they are out of phase can be expressed in degrees, from 0 degrees to 360 degrees. If the phase difference is 180 degrees, then the two oscillators are said to be completely out of phase, and they'll cancel when mixed together, making no sound. Time is sometimes used instead of degrees to express position within the cycle of a waveform. A phase difference is similar to two athletes running a race at the same speed and direction, but starting at different positions on the track. They pass each point or marker at different times, but the time difference or phase shift between them is constant. If the two sounds were at different speeds or different frequencies, the phase difference is undefined and would only reflect different starting positions. Let's check this out. We have a 100 Hz sine wave here. Let's see what it sounds like. And notice the volume is set to 0 VU on the master bus. So now let's duplicate this on another track. Obviously the two waves line up perfectly. This goes up and then down. They're perfectly in phase. Now let's watch the meter when we add them together. It's twice as loud, or +6. When you double the sound, it gets 6 dB louder. So now if we move this, or shift it, by 90 degrees, which is about here, notice the 0 point matches the tallest point here, 0 point here matches the tallest point here, the lowest point here matches the 0 point here. So there's going to be some phase cancellation, but not completely. So instead of being +6, it's now +3. So half the sound is being canceled. Let's move it a little further. 180 degrees, right here. So now the waves are exactly the opposite. This goes down, this goes up, this goes up, this goes down. At every given moment, where this is negative, this is positive, where this is positive, this is negative. And it should be exact, so we should hear nothing. And we do. Nothing on the meter. If we shift it even further, to 270 degrees, it's very similar to 90 degrees. Again, the 0 point meets the lowest point, 0 here meets the highest point. So again, it should cancel out, but not fully. Again, it's +3. So half the signal is being canceled. And if we go further, now it's 360 degrees. So now if you notice, it looks exactly the same. This goes up, this goes up. This goes down, this goes down. So it basically cycles to start over again. So it should be +6 again. And it is, right here. And everything in between. So if we bring it back to the beginning, we're at 6 dB. We could slowly bring it up. Notice some cancellation. A little more, even more, until it cancels out completely. So that's how that works. Technically, phase difference between two sounds at different frequencies is not going to be an issue and shouldn't cause any problems with audio. So we wouldn't concern ourselves with lining up the waveforms of our hi-hats with our kick drums for phase reasons. It won't really matter. Which brings up another point. The phase relationship between two signals matters more with low frequency information than it does with high frequency sources. So it's more important to line up our bass tracks, if we're using more than one, than it is to line up multiple shaker microphones. And phase cancellation will be more noticeable in the low end. Another common misconception regarding phase is the difference between phase and polarity. Many people use these terms interchangeably, but they are different. Most analog consoles and DAWs have a polarity button right on the channel. Pro Tools doesn't have one yet, but you can use plugins to do the same thing. Because phase deals with timing, this can't really be a phase button, as it doesn't shift the timing of our signal. Instead, it flips the polarity to make our waveforms invert. So instead of this waveform going up and then down, it will go down and then up. Exactly the opposite. But it can be used to fix phase issues, but it's not really a phase button. It reverses the polarity. And if we mix the inverted signal with the original, the result would cancel completely, just like adding a signal that is 180 degrees out of phase. Also, a complicated waveform can't be time shifted to cancel out, like we can with a simple waveform. But any waveform that has its polarity flipped or inverted will cancel with the original, and that can be useful for many things, as you'll see. So if we're back with this waveform, we could duplicate it, shift it, and it'll cancel because it's out of phase. Or we could invert it. So now it's like this, and this will also cancel. Except there's no phase shift. There's no space between here and here. They both start at the same point. And if we're using something more complicated like this, a drum part, there's no way of shifting this to cancel out. It just sounds phasey. There's no way of lining it up perfectly by shifting it because it's more complex. But we can invert it. And this will cancel perfectly. So no matter how complex this is, inverting the polarity will still cancel when mixed together. And that's the difference between phase and polarity. So why is phase important? To be honest, it really only matters in specific situations. Every track on a DAW is not going to need to be phase adjusted to work with all the other tracks, especially ones that are recorded as overdubs using one mic at a time. So while you might want to line up all your vocal tracks to be in time with each other, you wouldn't do it for phase-related reasons or phase issues. A good example of where this does become important is with a multiple mic setup. If we had two different microphones on the same source, phase issues could cause some of the signal to sound smeared or phasey when they mix together. This could be fixed by moving the mics around to either be in better physical positions, or we could flip a polarity button, or both. It's also important to realize that having two signals being perfectly in phase isn't always what we're trying to achieve. Many times it's not even possible. The signal will be too different to be exact, but it's almost always possible to get really good results by trying different techniques to reduce phase issues. And that's why it's important to know this stuff. Tracks with serious phase issues tend to sound very weak or anemic compared to tracks that are mostly in phase. So let's move on and learn more about using and fixing phase. Let's go.